This is the Ukrainian UJ-22 drone. What's so special about this drone is it can really fly very long distances from Ukraine to Moscow using basic technology with a very low budget of just around $90,000. At first glance, it resembles a miniature Cessna aircraft, showcasing a sleek and aerodynamic design. Primarily designed as a surveillance platform, but this drone can also be weaponized. By equipping it with up to 4 mortar rounds mounted beneath its fuselage, these weapons are controlled remotely by a weapons systems officer working in tandem with the drone's pilot, both stationed hundreds of miles away. This allows operators to execute precision strikes and surveillance missions while remaining far from the battlefield. More details all in the video ahead. At the front of the UAV, a 2-stroke internal combustion engine is positioned, equipped with a pulling propeller mounted in the nose of the airframe, similar to the design of a Cessna aircraft. Fuel for the engine is supplied by a small fuel tank located towards the rear of the drone. Remarkably, this configuration allows the UAV to achieve a range of up to 800 kilometers, making it highly efficient for long-distance operations. In addition to its propulsion system, the UAV also functions as a surveillance drone. A camera is mounted at the front, allowing for real-time monitoring and data collection. Although not fully confirmed, it is suspected that some of the visible components near the front may serve as flight controllers responsible for managing navigation and flight stability. At the rear, there is a battery that powers the motherboard, which in turn controls the UAV's ailerons, rudder, and other flight control surfaces. On March 30, 2022, the Russians shot a UJ-22 airborne unmanned aerial vehicle in Ukraine by the Pantsir missile and gun system. The drone was carrying an aerial bomb and an 82mm caliber mortar round under its belly. As stated, the drones have a relatively low speed. That's why the crew of the Pantsir as combat vehicle radar warning system detected the Ukrainian Armed Forces unmanned aerial vehicle and destroyed it with a single missile. The Pantsir missile and gun system crews are responsible for monitoring and securing the airspace in designated areas, typically a few kilometers from populated regions, to ensure the safety of civilians. Once a target is detected, the Pantsir system tracks and destroys it at a range of up to 20 kilometers before relocating. Since the beginning of the operation, Russian Pantsir missile defense systems have reportedly destroyed more than 400 drones and numerous military aircraft. Let's put an average person against this UJ-22 for comparison. It has a wingspan of 4.2 meters and a length of 3.7 meters. This drone is designed as a scaled-down version of what is likely a Cessna aircraft. It's powered by a gasoline engine reaching speeds of up to 200 kilometers per hour, which translates to 124 miles per hour. Additionally, it can fly at an altitude of up to 5,000 meters and has a maximum endurance of 8 hours. The drone's maximum flight range extends up to 800 kilometers, enabling it to conduct long-range missions deep into Russian territory effectively. It is also equipped with racks capable of carrying payloads of up to 20 kilograms, translating to around 44 pounds. Furthermore, it can carry various munitions such as bombs, mines, or other weaponry. The drone can transport 4 82mm mortar mines or up to 6 PG-7 VM munitions from the RPG-7 anti-tank rocket launcher. It can either drop the payload or dive right straight into the targets, creating an explosion or blast radius equivalent to the 4 mortars. The UJ-22 Airborne is a long-range attack drone that costs around $90,000 per unit. Let's take a look at how it operates through a simplified animation. Although this may appear simple, operating the drone requires an advanced ground control station and a tracking antenna to manage its flight. The ground control station and tracking antenna are placed far apart to reduce the risk of counterattacks if they are detected. The drone's communication system uses both a digital, two-way encrypted microwave data channel and a UHF data channel, ensuring secure communication between the ground control station and the aircraft. Command and control of the drone are managed by 2 people, the pilot and the payload operator. The payload operator is responsible for deploying the mortars when the drone has reached its designated target. According to reports, the UJ-22 can loiter for approximately 7 hours, waiting for the target to emerge, particularly if it is a mobile target. Once the target is identified, the operator can deploy its weapon's payload, releasing multiple shell onto the target. Additionally, The UJ-22 could potentially be modified into an improvised kamikaze drone by incorporating an internal warhead. So what's the big deal about these inexpensive drones? For example, a single S-400 missile can cost anywhere between $300,000 and $1 million, while an entire regiment of the S-400 system is priced at approximately $500 million. The concept involves launching these $90,000 UAVs to overwhelm the S-400 system, thereby enabling ATACMS missiles to successfully strike their intended targets. But the Russians have been building electronic warfare and mobile trucks to counter radio-assisted drones. These systems work by jamming the radio signals between the drone and its pilot, effectively disrupting communication and control. When this happens, the pilot loses the ability to see and control the drone, which can lead to mission failure. To counter these tactics, the Ukrainians have developed an effective solution, deploying an additional drone to act as a signal enhancer. This secondary drone strengthens the connection between the primary drone and the pilot, ensuring a stable link even in the presence of electronic interference. By boosting the signal, this method helps to neutralize the impact of the enemy's electronic warfare units. With this enhanced connection, the pilot regains control and can continue to maneuver the drone toward its designated target, maintaining operational effectiveness despite the enemy's attempts to jam communications. This seemingly simple, low-budget setup is more complicated than it appears at the back end. We are now at the front line. Here we see a Russian T-80 tank positioned right beside Russian trenches well dug for cover. Just 1 or 2 kilometers further back lies the Ukrainian trench. Moving 2 to 5 kilometers away from the front line, we find these short-range drones, also known as FPV, stationed here. Further back, we reach the long-range drone headquarters, and finally, we arrive at the brigade headquarters. Let's take a look at how this system operates. In Step 1, at around 25 kilometers from the front line, a communication drone will ascend to about 2,500 meters. This drone scans the battlefield and transmits the target coordinates to the FPV drones. Moving to Step 2. Once the drones identify a target, be it troops, vehicles, or artillery, the crews relay the coordinates to their commanders. Step 3. The commanders then receive the target information and decide whether to initiate a strike. Finally, at Step 4. Once the command is given, the drone is deployed and dives straight into a high-value target, such as a tank. The first step in countering drones with electronic warfare involves employing an electronic warfare truck, which can be highly effective within a radius of approximately 10 kilometers, or about 6.2 miles. This capability is critical for the protection of high-value assets, such as advanced air defense systems like the S-300. These systems are not only essential for national defense, but are also significant investments, with a basic unit typically costing around $150 million. The second phase of electronic warfare against drones relies on the system's ability to emit multiple powerful radio waves. These waves are designed to overwhelm and disrupt the communication signals of first-person view drones, which rely on steady radio connections to operate effectively. By overpowering the drone's control frequencies, the electronic warfare system creates an environment where enemy drones struggle to maintain functionality. In the final stage, once a drone enters the area covered by the electronic warfare system, it loses its link to the pilot, rendering it uncontrollable. At this point, the drone either crashes to the ground or continues to follow its last received command, as it is no longer able to link further instructions. In response to the increasing challenges posed by electronic warfare systems, Ukraine and Russia are racing to develop drones guided by artificial intelligence. Let's take a closer look at how this works. Imagine this dome as the area where the electronic warfare unit is located. As soon as the artificial intelligence automatically identifies a high-value target, it locks onto it. The drone is immune to jamming because once it locks onto the target, no further contact with the pilot is necessary. It then dives straight into the target, even without any radio signals. We also make original engineering content, so please subscribe and hit the notification bell for more videos.